It's time to level up. In this video, I want to show you 3 different architectures using scriptable objects. By the end of this video, you will have a solid understanding of how to use scriptable objects for more advanced, flexible game architecture. Let's get started. Let's start with using scriptable objects for AI. This is really cool. We start with an abstract AI state class inherited from scriptable object. Abstract classes can contain abstract methods, meaning they have no definition and can only be defined in a child class. We have an abstract method executeState, which takes in an enemy AI. Guys, this will be the base class for different AI behaviors like patrol state or chase state. And this abstract method will allow each child class to have its own unique behavior. Okay? For example, we can create a new class called patrol state and derive it from AI state. This allows us to add variables that are specific to patrol state. Next, create an enemy AI mono behavior. It holds a reference to the current state and enemy specific data like waypoints. It calls currentState.executeState function every frame and a switch state function to change states when the conditions are met, like when the player is in range. Back in the patrol state, we override the executeState method from our base class to implement patrolling logic using the enemy's waypoints. Don't forget, we need to mark this scriptable object with createAssetMenu attribute for easy creation. Here's the cool part. We can duplicate and tweak assets for different enemies without touching code. But what exactly have we accomplished here? With mono behavior, each enemy would have redundant variables for shared values. Scriptable objects centralize these, saving memory and encapsulating logic into reusable assets. Common data is shared while enemy-specific variables like waypoints stay in the enemy class. This keeps the enemy focused on its current state and not the patrolling logic. While the setup is more complex and requires more assets, the big advantage is reusability across future projects for the rest of your life. Next up is polymorphism. Now don't worry if that sounds super technical, it's really not that bad. Polymorphism with scriptable objects means you can create a base scriptable object class and then have multiple child classes that behave differently. Let's take an example with items in an inventory. We can create a base item class and then make child classes for specific items like a sword, potion, etc. Each item can override the base behavior with its own unique logic. Here we have created 2 items, a sword and a potion. Both inherit from the base item class, but their use method does something completely different. Now we don't need fields of type sword and potion. We instead could directly create a field of the parent item class, and we can still assign a sword and a potion to that field. Now when we call the use method on these items, we get different behavior depending on which object we are using. This concept is really useful and will change the way you code. Make sure to take advantage of protected variables as they are inherited by child classes unlike private variables. They are so useful. Now let's talk about something more advanced. Dependency injection using scriptable objects. That might sound intimidating, but let me break it down. This is a design pattern where we inject dependencies into scripts from the outside instead of hard coding them. This makes assets more modular and reusable. For example, objects like enemies, weapons, players, or barrels might have their own damage logic. Normally, you would write this logic in their classes. But if you want to change how damage works, you would need to update every class, which is a tedious and error-prone process. Instead, we centralize damage calculation using a scriptable object called damage service. Service is just a fancy term for a class that provides a specific functionality. The damage service handles damage calculation through a calculate damage method, which multiplies base damage by a multiplier for now. This function is virtual, allowing child classes to override it if necessary. You can see that class inheritance is a common theme when it comes to game architecture. There's also another virtual function, apply damage, which interacts with targets, implementing an iDamageable interface. An interface is simply a contract saying, hey, this class implementing the interface will define certain functions inside it. Interfaces like iDamageable let us standardize functionality across different objects like players, enemies, barrels, while keeping their specific implementations separate. Now, all of these are damageable, but how they receive damage will be customized on their individual classes. Now, in objects that inflict damage, we reference the damage service scriptable object. Notice that we're not hard coding the damage calculation here. Instead, we have a damage service reference which we'll assign in the inspector. During attack, we call the damage service.calculateDamage method to get the final damage. The inflictor doesn't care about the logic. It just relies on the service, making it easy to swap in different damage logic without changing the original class. The inflictor doesn't need to know if it is the player or not. It just needs to know whether the target it is attacking is iDamageable. I know this can feel complicated, and it is supposed to. I didn't get this on my first try either, but rewatch this part a couple of times again and it will make sense, I promise. Or better, open Unity and write this code yourself. By the way, all of the code I've shared in this video will be available to download from the GitHub link in the description. Now let's see the true power of dependency injection with a practical example. With collectibles using the same damage service we made earlier. I'm using the free collectible system I have made for this example. You can check it out after the end of this video. Okay? Suppose we have a fire rune pickup that adds burn damage over time. We can create a fire burn damage service class that inherits from damage service and introduces burn specific properties. And here's the beauty of this thing. By adding a new interface, iBurnable, we ensure only burnable objects are affected. For example, characters immune to fire won't need to implement iBurnable. We then override the apply damage function and check if the iDamageable target is also an burnable target to apply the burn effect. This approach lets you expand your damage system endlessly. It's clean, modular, and endlessly reusable. Of course, scriptable objects have their downfall, as it takes a lot of time to set up. But in the long run, I think these are worth it. Okay, I hope this video was useful. Let me know in the comments if you need even further explanation or dedicated videos on these topics. I will see you in the next one. Take care.